Thank you, Manuel Hassan, for introducing rowhammer vulnerability. As you may have thought, rowhammer sounds like a very unpredictable vulnerability. You usually don't know which bit you can manipulate and which bit you can flip. This is why I am introducing Flip Feng Shui. This is a technique that is based on rowhammer but is used to do guided attacks. If you are curious, Feng Shui is an ancient Chinese art of arranging buildings, objects, and space in an environment. This attack is used to precisely compromise services in cloud, browser, and mobile environment. Let's give a formal definition. Flip Feng Shui is a sophisticated rowhammer-based attack that manipulates memory layout to induce targeted bit flips, enabling precise control over which bits are flipped in the memory. Let us break down the definition. We get two parts. The first is finding the reproducible hardware bit flip, and the second is the ability to target that bit flip. There are three steps involved in a Flip Feng Shui attack. The first is memory templating, where we scan memory for useful bit flips. The second is landing sensitive data on vulnerable locations. The last is reproducing the bit flip. Here we modify the sensitive data to compromise the system. From the three attack scenarios mentioned earlier, I'll present the first scenario, which is compromising the cloud. In cloud hosting, there are multiple virtual machines hosted on a single physical machine. They have the same underlying resources. We exploit memory deduplication feature in virtual machines to use the rowhammer attack. Before going into the attack, let me tell you what memory deduplication is. This is a feature used by most cloud providers to free up space. Operating system actively looks for pages in memory that is common to multiple virtual machines. It then keeps only one copy of the page and frees up the rest to optimize for cost. Then it redirects the virtual addresses in those virtual machines to that physical address. This is used by most cloud providers to reduce cost, but we can use this to change the data in those cells using rowhammer, which breaks the virtual machine isolation introduced by the hypervisor. Virtual machines are typically accessed via SSH. Instead of using passwords repeatedly to authenticate, we can use RSA key pair for authentication. This is done by using a public key and private key pair. What makes it powerful is that the keys are generated by multiplying two large prime numbers. To crack the key, we need to find those primes, which takes a lot of time. But if we also store the public key in our VM, we can then modify the key pair using rowhammer, which will make sure the change is also reflected in the victim VM. Flipping any single bit makes it factorizable by multiple smaller primes instead of two large primes. This brings down decryption time from hundreds or thousands of years to just a few seconds. Another attack can be compromising the apt-get mirrors. This is where the virtual machine gets its updates and security patches. There are lists containing links to download the updates from and also a GPG key verifying the links. We can easily manipulate both of them using rowhammer to make the VM download patches from a different site than the original and potentially make it download updates from a site controlled by the attacker. I have presented the first scenario. The other two will now be presented by another team member, Asanul Haq. Thank you.